Everyone, hello. It's Elliot here. I'm obviously host of Enginears. We've got Aidan with us today. Aidan's at Hadean. He's the VP of Product. He's got a strong engineering background. He's going to talk to us a little bit about who Hadean are. Some of you might know them. Some of you may not. Naturally. But he's going to talk to us a little bit about distributed computing, platform as a service, and he's going to throw in some information and not necessarily anomalies, but some interesting points around open tracing, WebAssembly, when to use, when not to use, and some interesting points. So, Aidan, thanks for joining us.
Great to be here.
Thank you. Do you want to just give everyone just a bit of insight into Aidan, your background, and Hadean as a business? That would be really useful to understand that.
Yeah. So I started out as a kind of developer on a web application in a fairly underused language called Tickle or TCL. I then moved to Hadean to see new challenges and joined as developer number one. And one of the reasons behind that was I've been doing DevOps in this previous role, and Hadean was promising to tackle something that I had felt the pain of personally, and also was tackling quite a different thing to just building web applications. Since I joined as a developer, I became a team lead and then moved into product, which is where I am at the moment.
Well, what's that transition been like?
It's been really interesting. I think I've learned more in a startup in the assorted different roles that I've done. The in the same amount of time, about 10x the amount. Because I've been at Hadean 4 years, 4.5 years now, and it's just been amazing. So I've been doing kind of customer meetings face to face,
Yeah.
which I had never done before Hadean.
Okay.
And actually talking to the people who want to use your product is very much changed my mindset on a lot of things.
I bet they love you. I bet the engineers love you. I bet customers love you as well.
It's really nice talking to technical people who know the challenges, want to dig deeper into how you can help solve them. Yeah.
Yeah, I can imagine. How do you make that transition? By the way, I know this is not necessarily
Mm.
what we've discussed, but how do you make that transition if anyone's listening thinking, I'd quite like to do that?
Yeah, so honestly, I think that it starts out as a mindset thing. So kind of constantly being curious and saying, okay, there's this thing that I'm working on. Why am I working on this? What problem am I solving for the customer? Is there a better way to solve for the customer? And if you're working with kind of great product managers, they'll be doing a lot of this work as well, and you can pick up a lot from them.
Yeah,
And I think then, in terms of the mechanics of making the transition, it's a lot easier in a probably a lot easier in a startup because you can kind of say,
yeah,
I want to give this a go, and you can wear that different hat. But for I think technical people, having that curiosity and wanting to move in that direction is definitely a transition that can be made because you have a lot of technical context that will then help you, particularly when building technical products, which is what we're doing at Hadean.
yeah, yeah. I can imagine. We'll go into some of the challenges that Hadean face, and they're massively technical. But yeah, I can imagine that you're well loved. Understanding the tech piece, I can imagine that you're well loved. So, what sort of challenges, or who are Hadean? Talk to us about
Yeah.
who Hadean are, and yeah, talk to us about some of the challenges that you guys have.
Yeah. So Hadean was kind of created as a company, um, significantly to try and address some of the incidental complexities in distributed compute. So, from my previous experience, at my when I was doing DevOps at this previous company, I was kind of part of introducing Docker and containers to the 600-person company, and it was around the time of Docker 1.0 to 1.3,
Mhm.
and it was an incredibly painful experience. So I saw deadlocks in Docker, I saw crashes in the Linux kernel due to Docker, um, and the amount of tooling that was required around it just seemed astronomical
Okay.
and unnecessary. And what Hayden was promising was kind of, it doesn't have to be like this. Why can't you just write your application that with some scalable primitives that should scale and not have to think about the infrastructure, not have to think about that underlying complexity. And this is something that one of the founders experienced at their previous role as well. They were doing big data work. They wrote the kind of core algorithm of what they wanted to do in a very short space of time, and then spent multiple years trying to scale that using big data tools like Spark. Um, yeah, and so this is it's improved since then, like the containers ecosystem with Kubernetes and so on. But there's still obviously something missing there. So if you look at cloud providers, they don't just offer raw Kubernetes. They offer things like Fargate on AWS, which is run a container without thinking about any of the operational side. So that there is still this recognition of it being an unnecessary complexity.
Okay. So Fargate, for instance, is have it, have all of the bonus points that it gives it, or take away the pain, and that's what you guys do essentially.
Yeah, yeah, and what we're saying is exactly, and what we're trying to do is look at this from a more first principle. So, do you really need containers for all applications, or can you just use a binary? And that's the kind of thing that we pursue to try and try and make things more effective.
Okay. So you essentially distributed computing. If I simplify this for people who may not know, is essentially taking away, um, if you like, that infrastructure pain, or let's just say dedicated problem pain, and saying
Yeah,
we will take that off you. We offer that as a service. Go and do whatever you like on top of what we've already got.
yeah, and so the ultimately kind of distributed compute is kind of the very informal definition is like when you've got computation on a bunch of machines,
Okay, gotcha.
and so like you can't use you can't use things like threads and shared memory.
Okay,
A lot of patterns that you might like don't necessarily work, and it has a number of implications as well, like network partitions. So where the connection between two machines just vanishes, what are you going to do? How does your system respond in that situation? And there's a whole field of inspecting this kind of um, inspecting these kind of implications. And we want to make it tractable for people to work with this.
okay. So from that networking perspective, so
Mm.
will people have to set themselves up for Hadean to be able to integrate, if you like? They'll have to be distributed computing ready for you guys, if you
Mm.
like.
So one of the so at its lowest level,
Yeah.
Hadean tries to provide a set of scalable primitives.
Okay.
So things that allow you to create and allocate new units of compute,
Yeah.
and the resource allocation happens behind the scenes. You don't have to think about it, as well as establishing communication to these units of compute. At this lowest level, you can then build applications based on that.
Okay.
But this is a fairly low level piece of tooling for people who just want to run a big data problem. And so the strategy that Hadean has taken has said, okay, let's create some cardinal applications, distributed libraries, rather, that people can just take off the shelf and go, all right, my problem fits into this domain.
Yeah.
Let's write it using this library, and it will just automatically scale.
Yeah.
So the most kind of commercial ready one of these is Ether Engine for doing scalable simulation that we're working with a number of game studios on. And we also have the beginnings of something around big data libraries and so on.
Nice.
Uh,
I was going to say, are you able to tell us who some of the game studios are, or not really?
yeah. I mean, it's on our it's all public information on our blog. So we've done an extensive amount of work with CCP Games,
Okay.
who hold the world record for number of people in a single fleet fight, which was 6,142.
Okay.
But their challenge was this was very sub-real time.
Okay.
So they have a feature of their system where they slow down in-game time
Right.
so that their servers can handle the load.
Okay.
And so what they've been exploring with us is, can we use Hadean to eliminate that?
Okay. So they've actually slowed down the game time.
Yeah.
Okay.
Yeah. So a fight that would take kind of an hour might take 6.
Wow. So you've got lots of frustrated gamers everywhere.
Yeah. One thing that people like to or have historically characterized EVE Online as is a spreadsheet simulator. Not just for this reason, for other reasons as well, but it kind of gets across that mindset. But they'd like to make it real time, right?
Yeah.
What if you could have a 6,000 player battle that
In that hour.
yes, and we've done a number of playtests with them, live playtests where we've had a number of real players and a number of connected bots to stress the system in exactly the same way as real players would.
Yeah.
And we've exceeded 10,000 connections to these simulated worlds,
Good.
all real time.
Nice. Okay. So you're with CCP. Who else?
Yep. So we're currently exploring what we can do with Minecraft as well.
Wow.
Which, but that's still in kind of early stages.
Okay.
Microsoft's been a great partner for us. They've put us in touch with a number of their teams, and all of our tests were run on Azure. In fact,
Nice.
the Microsoft Azure cloud.
Nice. Okay. What are some real? You obviously handle gaming studios' technical challenges. What are your technical challenges?
Yeah.
What's really hard for you guys?
So I think one of the really difficult things is when building a distributed library, you want to make it general and applicable to a number of different use cases. But different game studios, in fact, let's just talk about scalable simulation.
Mm-hmm.
They have very different characteristics of their world. So, do they use physics at all, or do they not? Do they have complex AI? Do they want a tick rate of kind of 60 hertz, or is 15 hertz fine? So tick rate being how many time slices per second
Yeah.
the game world advances.
Okay.
And it's these kind of things have massive knock-on effects to um, how the simulation engine needs to respond to this. And so one of the things that we've spent a lot of time doing is trying to open up the Ether engine so that people can reach into the internals and customize it the way that they want. So they ultimately, the game designer, the game studio are the experts about their game, about the way players will play it, and so on. And we want to give them the power to say, kind of, hey, you need to scale in this way. So the canonical example I like to give of this is if you have a spaceship the size of a city that's coming in to crash land on a planet, on a forest, and there's going to be a ton of physics collisions and resolutions needing to
Yeah.
happen. The game designer wants to be able to say ahead of time, hey, we're going to need a load of extra resources in this area.
Yeah.
Please, like, add a number of new cells, which is the partitions of the game world. Add a bunch of new cells in this area, so that when it happens, there's no kind of blip in the experience for players.
Okay.
And that's the kind of extensibility that we're trying to enable.
Okay. Customization makes
Yeah,
sense. Everyone's going to have very different challenges based on what they want their players and users to see,
absolutely,
right?
absolutely.
What other hard challenges can you think about that you find difficult to solve? And I love the relation to understanding use cases or individual use
Yeah,
cases, because that's what it's all about, right? That's what
yeah.
you're offering as a service. So I understand that's hard. What other really hard, tech challenges have you guys got?
Yeah, so I guess in a somewhat similar vein, in terms of theme about ultimately the game design as the expert, is netcode. So when creating a game, game studios want to require a very low bandwidth connection to players because it makes a better experience. Um, and like if you have poor netcode, it can mean that it saturates people's bandwidth. If there's a blip in the connection, it goes horribly wrong, and so on. But so like a number of game studios are experts at this and will have network engineers who spend a lot of time customizing it.
Okay.
CCP Games is well known for having very good netcode, in fact, and very low netcode requirements.
Okay.
I've very low network requirements. But on the flip side, a number of game studios don't have network engineers and don't want to, but they still want to run games with tens of thousands of players.
Yeah.
And that's something that requires an amount of expertise. So one of the things that we've had to do in house is actually spend a lot of time kind of developing some out of the box netcode that people can just use off the shelf or use parts of off the shelf to be able to have those 10,000 people connected without saturating their bandwidth or breaking the bank on cloud bandwidth, which, as an aside, is astonishingly expensive.
Okay. Okay. Nice. Where does, and I know this because obviously we've spoken about this offline, excuse me.
Mm,
Where does Rust come into this? We've spoken about Rust on the podcast before
mm,
with a company called TrueLayer, and how they evolved from some basic scripts with Rust
yeah.
into actually building or moving one of their mission critical services to Rust. So, can you talk to us about Rust, how it was introduced, if it was
Yeah.
your idea, why? Because there'll be people listening that maybe want to go and have a play around, maybe want to start doing something similar. So what does the power of Rust give you?
Yeah. So it's different for everyone depending on their kind of their story. So for me, my first look at Rust came at the tail end of my previous job. So I've been doing a lot of TCL/Tickle, um, and I started writing as part of my DevOps work. I started writing a number of scripts in Python, um, and I started needing to use C as a low-level language for Python to communicate with uh, Tickle. And what I found, having come from these high-level dynamic languages without thinking about memory, is that my overriding feeling whenever working with C code was terror. That uh, it, I'd write something and it'd be very difficult to go, is this correct? Is it going to segfault? Is it going to do some other horrible thing? Um, it was just something that required constant paranoia to get something working, that and something that I would feel confident that it would work.
Mm-hmm.
Um, and so I heard about Rust in passing, and I heard that it was approaching 1.0. So I thought, hey, it'd be cool to give this a look. Um, I've
Go
obviously,
back to my Docker stresses with 1.0 and yeah, go
well,
do that
indeed,
again.
I hadn't had enough pain.
Yeah,
Yeah,
wanted more.
yes, exactly. And I'd used Go a bit in the past, but it requires a garbage collector, and or didn't at the time have that same easy interaction with C libraries.
Okay.
So I gave Rust a go, and I found it quite almost comforting that if I wrote something,
Yeah.
and whereas in C it would have been like, yeah, that's cool, let's go, and then with segfault, with Rust it kind of said, that's not going to work. You need
Okay.
to, like, this is wrong with it. You need to change that. And that was a very liberating experience. And so one of the reasons I joined Hadean, aside from this DevOps pain, was because Rust was because they were investigating Rust as an alternative to some of the C code that they were writing. Um, and it's interesting when I joined Hadean, one of the first things I did was fix a segfault in some C
Were
code.
you like, no, not again?
Yeah, exactly. And so for the component that I was in charge of, kind of creating, I wrote it fully in Rust,
Yeah.
and uh, it just worked really. The kind of there's the uh, there was a learning curve. I'll be honest
Yeah.
for me, because coming from a dynamic language, it's uh, you're introduced to concerns that you didn't have to think about before. I kind of knew about them, but hadn't internalized the rules that make it easy to work with explicit memory.
Okay.
But my understanding from people who know C++ is it's a relatively easy onboarding experience.
Okay.
If you've internalized those best practices,
Hmm.
then Rust just formalizes it as part of the compilation process.
Nice.
And so we use Rust as a foundation for much of for Hadean, and in fact that 10,000 player battle
Yeah.
was running on Ether Engine, which is in C++,
Yeah.
on top of the Hadean platform, which is in Rust. And
Awesome.
it's been
Okay.
a very reliable part of our stack.
Love that. Well, why should someone think about using this at the moment? As in, let's just say if someone's in trading, highly unlikely they're going to start moving things to Rust, or I can imagine. Why would someone think about this or using Rust, do you think?
Yeah. So I think the advantages that I see from Rust are if you have, I mean, it depends where you're coming from. So if you're coming from C and C++ and you have problems with segfaults, then Rust could be a good choice. If you use C and C++ and you are scared of hiring more junior people because of the risk of that kind of problem, Rust might be a good choice. If you're using Go and you're finding the memory consumption to be difficult to manage, or you want like really great interoperability with C, then maybe Rust might be worth looking into. If you're coming from Python and you want something fast, the classic way to incrementally do this is to write a extension in C.
Yeah.
But and this is something that I've been doing recently. I've been rewriting some in my spare time as a personal project, rewriting some bits of Python in Rust
Nice.
and using a Rust extension instead.
Okay.
So it's quite versatile. It's wherever you could have used C,
Yeah.
Rust is a reasonable replacement.
Okay.
But like there are downsides. Like I'm on the Rust infra and core
Yeah.
teams. And so I don't want to give the impression that it's like all wonderful,
Yeah.
because Rust is, although it's used by kind of Dropbox, Facebook, Microsoft,
Yeah.
it's still in relatively early stages.
Okay.
So in terms of its developer adoption,
Okay.
it's harder to find a Rust developer than a Python developer. So it's not the end of the world. If you've got a C++ programmer, they can onboard,
Yeah.
and that's what we've done at Hadean. But
Another advantage I can imagine, then you've probably got more hair if you're a Rust developer than you do with a C developer. Tearing your hair
I
out.
find that to be the case, certainly. I definitely find that to be the case. We've got an internal wiki page at Hadean
Right.
that records the time that we've lost to segfaults and undefined behavior and
Okay.
memory corruption.
Yeah.
And even our most expert C++ developer has an entry on that page
Oh.
where they just did something that, and they were kind of very embarrassed when they found out. They were like, I never do this. It's to do with iterator invalidation, for
Okay.
those familiar with C++.
It's quite funny.
Um, yeah,
At least you can look at the bright side or the funny
yeah,
side of it.
yeah, exactly. It's a reinforcement to continue using Rust where
Good.
possible.
Yeah. Look at all the bad times we've had. Keep going.
Yeah, exactly.
Um, how tough is that, by the way? Because you've spoken about memory, garbage collectors in Go. There's obviously positives, negatives. I'm intrigued. What does that actually look like at a company when you're making that decision on what stack is going to be best for us? Because,
Yeah.
like you say, there's going to be pros and cons, but how do you actually do that, and how do you actually come down to a decision?
Mm. So I think ultimately the important thing is to make a decision. Um, like the worst thing is to get hung up so much on language choice that you never progress. Um, the I think what I would be tempted to start with doing is using a language that the people who you're working with are familiar with,
Okay.
because it's just a good default choice. Now, those are the kind of rules of thumb that I would start with,
Yeah.
but you wouldn't end up with Rust on that basis. And so, to what you then, I guess, need to start doing is looking at, well, what are the requirements that we have about our system, about our work. So the reason Ether Engine is written in C++ is because we want game developers
Mhm.
to be using it, developing against it. And for better or worse, the primary language in the gaming industry is C++,
Yeah.
though C# is gaining popularity with Unity.
Yeah.
So that made our decision. Like, our customers want it. Um, there's some interest about Rust in the games industry, but it's not enough. On the flip side, a core internal component needs to be high performance, very reliable.
Yeah.
So that the implications there are probably no garbage collector, because we
Okay.
want to have predictable performance, highly reliable. So we want something that's got types. We probably want something compiled. And so ultimately that narrows the field massively to things like C, C++, that's the obvious contenders, D, Rust, um, potentially NIM. But of those, I think that Rust, C, and C++ are the most popular. And then you start going, well, how much have I experienced the pain of undefined behavior in the past?
Yeah.
If you're and if you look around online, there are stories from experts who say, look, even expert C++ developers uh, can't write flawless C++ code. It's not possible.
Yeah.
So if you look at Firefox,
Yeah.
one of the reasons, huge C++ code base, one of the reasons Rust was created is to replace parts of the C++ with Rust.
Gotcha. Okay. Interesting. Um, I just see it naturally. I see startups, obviously, when you want to build something, get it out to market and test what your customers think. People do go for speed, and they think
Yeah,
about Ruby, Go, others. Um, but it's just interesting looking at the full spectrum. And you're right, you've probably got to think about your people and
absolutely.
your people capabilities, and what's going to be best for you internally. So okay, that's interesting, and I think hiring as well, like you said, hiring's a big one. If
Hiring's always hard.
Yeah, it is. Hiring's always hard, and if you're looking to be different, just to be different, you're going to make it really difficult for yourself when it comes
Yeah.
to hiring if you're going to be really hung up on some of these things.
Yeah, so I'm a big fan of Erlang. So
Okay.
I've done some Erlang in the past, and I love it as a language. But I would be very hesitant to use Erlang or Elixir as a foundation for a company,
Okay.
just because the it's hard enough hiring.
Yeah. Yeah. Yeah.
Hiring for those skills is unless I have a really solid training program
Yeah.
where I can be like, okay, you're a Python developer, now I'm going to onboard you into Elixir,
Yeah.
then maybe, but it's very, it's a risk ultimately,
Yeah.
and it's maybe a risk that you don't want to take.
Okay. Are those two? Is there, I guess, a mix between the two languages that there's some crossover where engineers could cross train?
So you mean between
Python and Elixir?
Python and, I think, so Elixir is built on top of Erlang as a
Yeah.
language, and then but with a more Ruby-like syntax.
Okay.
So Erlang has very alien syntax for people coming from Ruby or Python. I'm a big fan of it personally, but I like Prolog, so that I'm potentially outside of the norm. So I just say that because it has more familiarity for people who've come from there.
Yeah. Okay. There's a couple of bits that you touched on when you were talking about languages, actually, that I think would be quite useful to understand. I'm especially
Mm.
keen to understand. You're offering a platform as a service, essentially.
Yeah,
Um, how do you, Hadean, ensure performance, reliability, obviously availability, and other abilities are going to be really important for you? So, is there an
yeah.
ethos? Is there a code of conduct, principles? What underpins what you guys offer as a platform as a service?
Yeah, so uh, It's a really interesting question. I think one of the mindsets we have is that if it's a if it's a platform, it needs to be like an OS in terms of its like fundamental stability. It needs to be very forgiving about like what it accepts and the kind of classic programmer mantra of be forgiving in what you accept and strict in what you output.
Okay.
That's the kind of that's one of the things that we use to try and guide us on this. We also want to have, and one of the ways that we look at this is by trying to reduce the surface area
Okay.
of interaction.
Mm.
If you don't have like deeply complex interactions with the system, then you can look at the interfaces that you have and go, okay, let's make those absolutely rock solid. So rather than having an explosion of an API and whatever, and going, oh well, you've used API kind of 532 in this strange way. We've never seen anyone do that before. It should be, what if we only had 20 APIs and all of them are fuzzed, for example.
Okay.
And this is something that's a forever ongoing process. Reliability isn't something that you get out of the box,
Yeah.
and it's not something that people will believe without you having demonstrated it in production at
Really.
scale. Yeah. So one of the challenges that we have to overcome as a startup is for people saying, well, your approach sounds great. It aligns very well with my thinking as a technical person. I can see how it works great. I'd love to use it. My only hesitation is like I've not seen this running in production
Yeah.
for multiple months.
Yeah.
And it's just a challenge that we have to overcome ultimately.
How do you overcome that?
So one of the ways is by doing proof of concepts
Okay.
with these companies and saying, okay, here are the parameters that you're interested in investigating.
Yeah.
Let's prove to each other that we're a good fit for each other and that we can achieve the benchmarks that you have. Or you can go and do it yourself. So we've looked at the possibility of hosting something ourselves
Okay.
for multiple months and then saying, hey, look, we had this thing up and running. Here's what maintenance looked like. Here's what upgrades looked like. Here's what the uptime was, etc., etc. So,
Yeah. Nice.
and this is a nice way to prove it to yourself as well.
Okay.
Um,
Nice.
yeah, it's just an ongoing process, and there's no easy way around it.
Okay. What might moving some of your distributed computing to serverless architecture look like? I read something in one of your white papers online. So, what's behind that decision? What might that look like?
Yeah. So serverless is a really interesting trend. Um, so, and I think it's worth kind of just looking first at Heroku, which is like the one of the first platforms as a service that really got traction behind it. And its sweet spot was web applications, where you create something that can be hit by a user at an endpoint. And Heroku deals with all the infrastructure, all of the scaling. It can spin up multiple instances of your web app and so on. And the kind of natural extension of that kind of becomes functions as a service, where as soon as your endpoint is hit, a small function like comes up and running and handles the request, maybe talking to a
Yeah.
database, and gives you a response.
Mhm.
Dead simple. But this kind of serverless / functions as a service, and they're used interchangeably,
Yeah.
is very is kind of niche in that they're not designed for collaborating with each other.
Okay.
So in the case, well, obviously they're not designed for long running things, but they're not designed for being able to message each other. So in the case of um, uh, Ether Engine, if you have this grid of cells and they all want to talk to each other and this grid is dynamically changing, you need a way for these things to find each other and talk to each other.
Yeah.
And that's just not something that serverless is built for. And I think it's a bit of a shame that the word kind of functions as a service has been used for the same thing,
Okay.
because there's potentially an opportunity there to say, well, they're functions, then they need to talk to other functions and use it as a more general term.
Yeah.
But the way that it is they're used interchangeably for request comes in, deal with it, request goes out. Yeah.
Nice. Where does open tracing fit into everything? Because you're pretty excited about talking about that,
Yeah.
and investigating what's going on the inner workings, if you like. So,
Yeah.
to talk to the audience about open tracing. They may not have heard about this. So, what
Mm.
is it? What does it do for you?
Yeah, so one of the challenges with building a platform for distributed compute is that if you've got your program running across many machines, you now need to be able to debug across many machines. You need the tooling for doing that. So if you've used a debugger, be it the Visual Studio debugger or GDB, it's kind of built for single machine debugging, which is fine, but not overly useful if you're running across 100 different machines. Because you need to know where your problem is, SSH in, connect to the correct process on that machine of 100, and so on. So what we've spent a bunch of time doing in order to be able to offer this platform is building debugging tools. So building a step debugger that will work across many machines, by repurposing GDB for our own needs and extending it, but also adding kind of best practice things like open tracing.
Okay.
And open tracing is something that came out originally from Google. They have a paper about something called Dapper,
Okay.
and what it was built for is to say, okay, when you get a request into your system, and it goes to server A to find something which talks to internal server B, and that replies to server A and then goes to server C, etc. And you want to find out, well, eventually it'll return a response to the user. But what went on?
Yeah.
Like what took the
Okay.
time during that request?
Yeah.
But this may have happened across, 20 different machines. And so tracing is being able to say, well, for these particular spans of time,
Yeah.
it was doing X thing.
Yeah.
And then you have subspans. So, okay, while it was processing the overall request for the user, it talked to server B,
Yeah.
and server B talked to like some other service. And so you can, like, then for a particular request, you can see overall what's been going on.
Yeah.
So, okay, half of the time was on server B, half was on server C, and so on. And you can look down and go, the database, when I talked to it from server C5, was really slow for query X, which is something that would be extremely hard to reconstruct if you just had the logs from all of these places
Okay.
and you wanted to aggregate it all together. And what we've done is and this paper from Dapper became has become an open standard called open tracing.
Yeah.
And there are a number of different companies out there that offer tracing capabilities. So I think Datadog has it, Honeycomb,
Okay.
loads of them. But what we want to do is say, well, not everything is just a request response.
Yeah.
For the Ether engine, it's a long-running simulation.
Yeah.
It's not don't happen in response to user requests. They're just constantly happening. And so what we wanted to do was have a interface to tracing that allows you to use it for just general time logging.
Yeah.
So, and say, beginning here, ending here, what happened across these different machines? And this is something that we offer out of the box with our platform. You can say, hey, let's start this trace and follow through
Watching
the
this. Yeah.
communications, see what happens.
Nice. Okay. So essentially, looking at the inner workings of, or really, what's under the hood, what is happening under the
Yeah,
hood between communication. Nice. And I can imagine in gaming, those details, where you're offering your platform to customers at the moment, those details, they mean a lot. Those really, really
yeah,
small details, they mean so much to you, to them.
yeah. I mean, game developers are used to having really great profiling tools in their
Yeah.
game engine. Like, how much time did physics take? How much time did pathfinding take?
Yeah.
And then they're not going to want to give up on that just because they're running on multiple machines.
Yeah.
We need to have something that gives them a similar amount of power.
Okay. Okay. Nice. What about WebAssembly? Before we wrap up, talk to us about WebAssembly. I know it's on your mind, your to do. Again,
Yeah,
it's probably fairly new to the industry, I would say, and
yeah,
there's going to be people who are really excited about it. So, what do you know so far about WebAssembly? And again, why would you use this? Where?
yeah. So is the history of WebAssembly is kind of interesting.
Okay.
It came from a project from Mozilla to compile C and C++ programs to JavaScript, and this produced uh, a form of JavaScript that was known as ASM.js.
Okay.
That you wouldn't write it by hand, but it was um, very kind of carefully constructed to allow JavaScript, like just in time compilers, to easily optimize it.
Yeah.
And uh, and this compilation happened through a tool called Emscripten. And there were some very impressive demos based on this. So compiling the an Unreal Engine game engine demo to the web, which they did with Epic Games. I've spent a fair amount of time with Emscripten putting Python in the web and so on.
Yeah.
But JavaScript is not a very compact format
Yeah.
for kind of communicating binary code
Okay.
because it was emulating memory accesses and so on. So I had a memorable occasion where I ended up with a kind of 200 megabyte JavaScript file, which browsers struggle with.
Okay.
So WebAssembly was created as a kind of as a solution to this. It's in that it's both a compact binary format as well as being architecture and platform independent.
Okay.
And so you then need a WebAssembly interpreter
Okay.
to like run it, and so it starts sounding a little bit like the promise of Java bytecode.
Okay.
In fact, that you need the Java virtual machine to run it, but it's kind of platform and architecture agnostic. But WebAssembly is kind of lower level, so it's I won't go into the detail, but it's worth having a look at the differences,
Nice.
of which there are a number of write-ups.
Okay.
Where's WebAssembly useful? Primarily the web is where it's been targeted at to date. So you can compile your C, C++, Rust,
Yeah.
Go
Nice.
to WebAssembly and run it in the browser. So, and I've used this on a number of personal projects. So this isn't something that we've looked at so much in Hadean to date.
Okay.
But I've used it on a number of personal projects to be able to write Rust on the server side
Yeah.
and the client side.
Wow.
No
Okay.
JavaScript at
Interesting.
all anywhere.
Wow.
And that's a very that's very nice, because historically, if you want to
I bet
do
that's even more comforting for you. Rust,
yeah,
Rust was comforting as it is until WebAssembly turned up.
exactly, and there are some great choices on the front end these days, like TypeScript,
Yeah.
which I fully recommend. But being able to use the same language on client side and server side
Yeah.
has only been possible with JavaScript and its derivatives.
Okay.
Being able to do that for Rust is really cool.
Nice. Okay.
But and like WebAssembly has then evolved past the web to be actually, well, it's this safe, architecture independent blob of executable code that we can actually use wherever we like. So, for example, if you want to write a database plugin, but you don't trust like that it won't crash your database, so usually you might write your Postgres extension in maybe C.
Yeah.
You can write it in WebAssembly instead.
Nice.
And if that code inside the WebAssembly crashes, it's fine. You just return an error to your database, and it'll continue on.
Nice.
And so it's getting some adoption outside of the web as a just general binary kind of executable format, which is quite exciting.
Yeah. And did you say Epic Games are using it for is it their Unreal Engine?
So there was a demo that Mozilla and Epic Games collaborated on,
Okay.
but Epic Games does offer exporting a game to HTML5,
Right.
and I don't recall offhand if that uses WebAssembly or ASM.js.
Right.
But I think there's potentially debates around whether that continues, whether they continue offering that. But at least today, there are versions of the Unreal Engine where you can write a game and export it
Nice.
to HTML5 using it via WebAssembly or ASM.js.
Nice. There's some seriously good, interesting, and different content here around platform as a service and distributed computing. That was a really good overview. But Rust, Open Tracing, and WebAssembly. I want to say thank you. You know, it's been massively insightful. Is there anything that you want to share with us that you've got a burning desire to share about anything?
Mm.
Whether it's advice for engineers, someone coming into the industry, any advice?
Yeah, I guess the number one piece of advice is I've talked about all this exciting stuff that I personally am playing with,
Yeah,
that I'm very excited about,
yeah,
but it's very easy to get swept away in it all.
okay,
Right? And I kind of talked about the cautions I have with Rust, that it's not as easy to hire for Rust as Python,
yeah,
and I think it's the one thing I'd say is being cautious about being swept away in this excitement
nice.
versus actually going, well, this is a cool, like WebAssembly is so cool, like I can play with it in my spare time. It's got great applications, but do I need to use it right now?
Yeah,
Maybe not.
be pragmatic.
Exactly. That's always my focus, to be pragmatic about the use cases of things.
Yeah, great. And you said that actually first. I think around the customization point, you were talking about what's the use cases, think about the customers and your transition to
Yeah,
product.
yeah,
Yeah, prioritize that. And from my understanding, from talking to all of you fabulous people, that will put you in really good stead before you start running off with what's the best
yeah,
technology. A little bit like, for example, serverless and how it doesn't work for you in some instances. Um,
yeah,
yeah, don't try and force something.
yeah. Absolutely, absolutely.
Nice. if people are listening and they're interested, are you guys looking for engineers? Are you looking for product people? Explain.
Yeah, so we're definitely looking for product people at the moment. So the one of the challenges that we've had is it's a deeply technical product, right? One of the
Uh-oh.
like requirements is,
An
hey,
Aidan
I want a
times
debugger
two.
that works. Sorry?
An Aidan times two, or an Aidan clone.
Well, I mean, I wouldn't say no, but yeah, like creating the product requirements around a distributed debugger is not a straightforward task.
Okay.
Uh, and that's something that we're looking for. Yeah, we're always interested to hear from people who are passionate about this area. There aren't, we're not currently actively seeking out engineers, but that may change in a few months.
Okay.
So reaching out and then potentially we can get back in touch with you.
Yeah. So, audience, have a look at the white paper. Follow these guys. Set up alerts. See what's happening with them. Like, share. Give a big thank you to Aidan, and we'll see you all soon. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no underscore. We've also got a website which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.